and welcome back to Dynamics, second module, which is non-uniform motion. Now, the first thing that we'll go over in this module is frictional and drag forces, basically resistive forces, right? And what's the difference between drag and friction is a great gateway to understanding them, right? So the cause is obviously for both, it is motion, but for drag, motion through a fluid. Now, what the word fluid means is gas slash liquid, right? Whenever moving through a gas such as air or liquid such as water, uh, an object basically experiences a resistive force called drag, right? Now, friction is the same as drag in terms of motion, right? Because motion causes friction. But when moving through motion through solid surfaces, right? Solid surfaces. So that is friction, right? For example, a car moving across a road, right? For example, a car is moving across a road, so it experiences, pardon my bad car drawing, right? But it experiences two types of forces. The first force is because of this contact with the road, this car experiences friction, and because of moving across fluid, which is called air, which is air, right? In this case, air, it experiences a drag or viscous force, right? Now, no treatment of formulas is required. Just a simple model of drag force is increasing. Now, increase slash decrease, right? What causes an increase or decrease in these forces, right? Now, velocity through velocity through this is proportional to drag, right? Let me just write this first. Now, velocity through the fluid basically causes an increase or decrease in drag force. For example, if a car is moving at 20 meters per second, it will experience more viscous forces due to air resistance than a car moving with a speed of 10 meters per second. Now, this is not in your syllabus, but let me just, this is not in your syllabus. So let's just not go over what causes an increase in frictional forces. But if you are interested, basically how much you are pushing against the surface that you are moving across basically causes the increase and decrease in frictional forces, right? So move on. What objects experience high friction or high drag force, right? So denser objects, denser, let me just, denser and pointy objects experience less drag force, right? So what that means is, for example, you can even imagine this by yourself, right? An object that is, for example, a metal ball or a styrofoam ball, right? Moving in a water inside a container of water, moving downwards. The obviously the metal sphere will, even if they are the same weight, the metal sphere will reach the bottom quicker than the styrofoam ball, right? Or for example, you have seen this in real life many times. The movement of a feather downwards in air is very slow, right? So that's because it is very the feather basically isn't very dense, so it experiences very high amounts of drag forces. Now, for the friction is basically just this: however much you are pushing against the surface, the friction increases. Again, you don't need to know this for physics AS level. Now, the direction is always opposite to motion, right? The direction of the force caused by air resistance or friction is opposite to motion of the body, right? So this is just a basic understanding of resistive forces. Now, the concept of free fall, when an object is falling in a uniform gravitational field, right? Gravitational field with the only force acting is force due to gravity, which is also called weight, right? So this is free fall, but what we're going to discuss is a little bit different than free fall, which is falling in the presence of air, right? So now what I've written here is basically copy of the mark theme, and this is a question that is asked a lot, even if not in the form of basically falling through gravity. It the question is asked in some other forms, like a car moving with constant force of this initially, what will happen and how will it reach terminal velocity? Basically, this question is asked a lot in the exams. So I've written the whole mark scheme here, mark scheme type, basically answer here, and let's just go over it and understand the logic behind this. And I do recommend that you memorize this afterwards. So acceleration causes an increase in velocity, right? So for example, an object is falling in air, right? So the initial thing that is acting upon it is its weight, and the weight causes an acceleration, a constant acceleration of 9.81 in this case, right? So this causes an increase in velocity of the object. Now, this increased velocity, right, causes an increase in drag force. As the velocity keeps increasing, so does the drag force, right? With the velocity, the drag force keeps increasing. The next thing that happens is force of drag force is in opposite direction of weight. So resultant force keeps decreasing, right? So as the drag force increases, the overall force that the object experiences decreases, right? Thus, acceleration decreases as velocity increases, right? This is just a summary of what is happening in the previous three parts. Now, eventually, acceleration becomes zero as resultant force becomes zero. Now, what happens is the drag force increases so much, right? For example, this is an object and its weight is 5 Newton, for example. So the drag force increases so much that it also becomes 5 Newtons as the velocity of this box keeps increasing downwards, right? So this is drag force. This is weight, right? So the drag force increases so much that it becomes equal to the weight, right? And that is the point where the resultant force is zero and acceleration is zero. So the velocity at which the box is traveling now, for example, it was traveling at 20 meters per second downwards. So the velocity then becomes terminal velocity, right? Terminal velocity, which is the highest possible velocity of the box the object can obtain when falling through a fluid, right? I'll write the definition here. Highest. I have never seen the definition being tested of terminal velocity, but I'm just writing it down. Highest possible velocity attained when falling through a fluid, right? So that is basically it. What I recommend for you to do now is just go over this example, right? Go over this and maybe even memorize this if you want, but just you need to understand what the concept of this is so you can answer a question about terminal velocity or how an object reaches terminal velocity. Yeah, and that's basically it. What you, another thing you need to understand is basically what kind of object would experience low drag forces, how they increase, the drag forces increase basically. A little bit more on the drag force. Resistive force is basically they are caused by, at the particle level, the forces are caused by basically rubbing with the particles, right? When an object moves across something and it touches another particle, the particles rub off against each other, and that is basically the cause of resistive forces on a very small level, right? So if you wanted to know that, that's basically it. And the second module is basically over now. Thanks for watching the video. Do consider subscribing if I helped you out. And thanks for watching. Goodbye.